Okay, so in our last video we looked at how we solve a quadratic equation, and if we are actually remembering correctly, the last time we solved this quadratic equation, we had, let's see, we had that plus, what was it, 6x plus 5 is equal to 0, and we use the AC method with what we call the factorizing or the factoring method of that formula, or let's say that method. We use the factorizing method to actually solve the quadratic equation by finding the values of x. Now, as promised the last video, I told you that we were going to look at the quadratic formula and also completing the square formula to do the same, to solve the same question. I'm going to show you that you use both. You can use any one of the three methods, but sometimes the AC method doesn't work, or the factorizing method doesn't work, or the factoring method doesn't work, and so we normally would try to export other methods, and so we were looking at the quadratic formula and also the completing the square. Well, if time permits us, we probably look at the completing the square in this video. If not, then we look at the completing the square method in another short video. And so let's go and to solve this quadratic equation by using, well, the other two methods, well, any one of them for now. The last time we solved this by factorizing, or we use the AC method, we got x was equal to -5 and x was equal to 1. Let's see if when we use the quadratic formula, if we get the same thing. So remember, we have this equation, but what is the quadratic formula? How does it look? Well, if you remember the quadratic formula, it is x is equal to -b plus or minus the square root of b squared minus 4 times a times c, and everything divides by 2a. And so let's try to understand, what are these variables and so on. It's very simple. If we remember the general quadratic equation, just try to remember this. I should have written it in a different color so we don't see everything as one shade. Let's say we have ax squared plus bx plus c is equal to 0. And so we can actually see that this a represents this a and that a. This b is the same thing as this b, that b, and this c is actually this c. And so, this is a pretty good way. This formula can be used anytime. Whether the quadratic equation cannot be factorized, this is a formula that you always use. So you will get quadratic equations that cannot be factorized, or you can simplify the values of x. So we use the quadratic equation, so it is very reliable. So let's try to understand, how do we actually substitute these values in the quadratic equation? Alright, so this is actually the a square, the ax square. I know that the coefficient of this is 1, and so this represents a. Anywhere we see a, we put 1 there, because this a represents, that 1 represents a. Now this 6 represents that b and that b, and this 5 represents that. And once we have that, we are good to go. All we need to do is to substitute these values into the variables, in their respective variables, and we are good to go. So let's see. All right, let me see again. Let me get this a little bit smaller. All right, let's go. And so let's write x is equal to negative, what is b? B is 6 plus or minus the square root of 6 squared minus 4 times a times 5 all over 2 times 1. And so once we are actually here, we are good to go, because it's a simple substitution, and all we're going to do is now to evaluate this. So let's just do this very quickly and easily. So that gives it that plus that. Now if we were to actually multiply all of these and then if we find the square of that, let's see what we got. The square of 6 is what? 36. When you multiply everything here, we have a minus. 4 times 1 gives us 4, and 4 times 5 gives us 20. And if we should multiply what is in the denominator, we get 2. Let's go down. Oh, we have equal like that. This should be a negative right there. Right. And so we continue. So we have 6 plus or minus. What to say? If we should actually work with what is in the numerator, we get 16 all divided by 2. And we continue doing this, just simplifying it. Very easy, simplifying it as we go along. Equal minus 6 plus minus 6 plus or minus. And then we say, what is, well, we could actually find the square root of 16 right there. We don't have to rewrite this square root. So the square root of 16 is 4. And everything divides by 2. So let us actually write this in a simpler way to understand. So what is this saying? This is saying that x will have 2 values because we have a plus or a minus, and so x will be having 2 values. And let's see what is happening. And remember that anytime when we find the square root of a number, it is a positive or a plus, or it can have plus or minus. And so that plus or minus will give us 2 values by actually doing one by one. So let's go. So we have x is equal to minus 6. I'll choose the positive one first. It doesn't matter. Over 2. Or we could say x is equal to negative 6 minus 4 over 2, because this plus and minus is coming from this plus and this minus, and so you must share them. We do one with positive and we do one with negative, and so we just continue doing it. Let's just simplify it. It's very easy. So x is equal to 6, negative 6 plus, well, let's just work this out. So let's say we have so we owe $6 at the shop, we have $4 in the pocket. When we pay the $4, we are left with $2, and we divide it by 2. We know that this is negative 1. We got negative 1 when we do the factorizing, and so we're actually seeing that what we're doing is there's nothing wrong. We're actually doing the right thing. So x is equal to let's say you owe $6 at the shop. You go again and you trust some more things, and your bill is adding up. So you owe $10. You divide that by 2. That gives us negative 5. And so we can see that the quadratic formula gives us the same answer. It gave us the same answer. It gave us the same answer just as when we were factorizing the quadratic equation. And so now we know that the quadratic equation can always be used. The quadratic formula can always be used to solve the quadratic equation, well, any quadratic equation. And so this is a reliable method that you can always use. Well, let's see if we could actually use the complete in the square formula, or let's say method to solve this problem and to see if we get the same thing. So how does the complete in square concept look? So if you remember when we were completing the square, when we were actually writing a quadratic equation into the vertex form and all of that, and you see a thing like this. Let me see, square plus k is actually something looking like that. So it's an equation, so we actually equate it by 0. And so this is the concept that we're going to use. Always remember that our objective is to find the values of x. And so let's use the original. Let us use the same quadratic equation that we use for the factorizing method, which is the AC method, and the quadratic formula method. So let's use the same equation and to see if everything is correlating or corresponding. So we had x, what's that? X squared plus 6x plus 5 is equal to 0. What's the first rule when we're completing the square? The first rule that we factorize the equation, all the term by the coefficient of the x squared. So we bring that 1 outside. and if we get, so we would divide both everything by 1. Anything that we are factorizing the equation by, we divide it. We divide the coefficient of the x squared by each term in the equation. So we always do that to get back what is supposed to be in the bracket. So we have back x squared plus 6x plus 5 is equal to 0. Now this one is understood, so we don't have to have it there. We could just get rid of it. We could just simply just do this. But what do we do after this? We normally have b, and when we square it, we add 1 in this term, and when we have b, so b would be this, because we would have done complete square already in previous videos. And so we would have b. When we have b, we square it, we would add 1 to the x's and subtract 1 with the constant outside. Or you could just bring it across equation sign. See, this is no big deal. But let us just fix this up just a little bit before we do that. Let us just rewrite this. How do we know how to do this? So after factorizing each term by the coefficient of the x squared, what we do, we just write x squared plus 6x, have these by itself, and then we separate it by the constant 5. Well, we could actually just bring the 5 across here, and it will give us a -5. Because we're trying to get everything. We could even write it like, let us do it this then. Positive that. The aim is always to have x by itself, but let us take our time and do what we're doing. So we say, what do we do now? We have b, and we have it, we square it. The answer we get, we add 1 to the x's, and then we subtract 1 with what is outside. Cool. So let's go. So we will say, let's say we have, so what is half of b? Half of b is 6. When we square it, half of b, sorry, is 3. When we square it, we get 9. And so what we will do, we just add 9 in the bracket where the x's are, and subtract 9 outside. Very simple. And so what we do is we have now x squared plus 6x plus 9 close bracket plus 5 minus 9 equal to 0. Now we could just simply simplify this, or we could write this in the complete in the square form. And so what would that be? That would be x plus 3 all square minus 4. Make x the subject. So what we do, we want, so we get rid of this first. So what we do, we add both sides by 4. That cancels that. X plus 3 all square is equal to 4. What do we do after this? We just simply get rid of the square root. We square both sides. Square both sides. So that square root cancels that square, leaving us with x plus 3 is equal to plus or minus 2. And what do we do after that? Very simple. We just make x a subject. So what do? We subtract both sides by 3. That cancels that. X is equal to minus 3 plus or minus 2. And so x will actually give us 2 values. Let's see what x gives us. So let's see what x gives us. So x gives us x is equal to minus 3 plus 2. Or we could say x is equal to minus 3 minus 2. And let's work this out. Let's see what we got. If we were to work the first one at the top right here, we will get x is equal to, you owe $3 at the shop, you have $2 in your pocket, so you're owing back with 1. And then if we should look at this, we get negative 5. You owe $3 at the shop, you go again and you credit more things, and your bill comes up to $5, so you're owing 5. And there you go, we got the same answer, same solution. And so whenever you have a quadratic equation, and you could actually use the quadratic formula, you could even use the completing square, because the completing square method is actually an alternative way to solve a quadratic equation. Alright, so what we'll be looking at in the other video, we'll be looking at some problems. We're going to do some practice questions with solving quadratic equation using all the three methods. Looking at the quadratic the quadratic formula, the factorizing method, and also completing square. We'll be looking at problems that cannot be factorized if you were to use the AC method, which is what we call the factorizing method or the factoring method. And we're going to see how beautifully it will be solved by using the other methods that we explored. So there you go, solving quadratic equations by using the quadratic formula, using the factorizing formula or method, and the completing the square. Take care.